Okay, in this problem, we're given a boronite. The reactant is heated with oxygen. So we have a combustion reaction to extract the pure copper by the equation below, So 25.8 grams of the boronite reacts completely with excess of oxygen. So what it means is that boronite is a limiting reactant. So after the reaction, we're supposed to see zero. Nothing remains while you have abundant oxygen for the reaction to continue until the limiting reactant or limiting reagent runs out. And we're given that 5.0 grams of iron oxide is formed. Again, all came from the limiting reactant. So what you can do is that since this was produced, you can find out the amount of copper from another product you got. So 5 grams of FeO or iron 2 oxide, and then you need to find the molar mass of iron oxide from the periodic table, and iron should be 55.85 plus 16 for oxygen, so you get 71.85 grams, and that's 1 moles of iron 2 oxide. From that, we jump from the iron 2 oxide to copper. So in the balance reaction, every 2 moles of iron 2 oxide is being formed. 6 moles of copper is also being produced, and 1 moles of copper has 63.55 grams that you can look up in the periodic table. 5 divided by 71.85 times 6 over 2, which is 3, and times that by 63.55, you're gonna get 13.26 grams of copper. 13.267 grams of copper. We wanna need to keep 3 sig pig. So yeah, you can just think it as 3 sig pig. That will eventually round it up at the last step. So our goal now is to find the percent by mass of copper, since this amount will be formed from the initial 55.8 grams that are contaminated or that is impure. Alright, this is basically a sample. We multiply that by 100%, we should get something larger than 50%. You're gonna get 51.42%. Okay, and then we have to round it up to 3 sig pig. 51.4% of copper is percent by mass in the original ore sample. Okay, therefore the answer is C.